Defects in solids. In this module, you will learn about the various types of point defects present in the crystal lattice of solids. Crystalline solids have a regular arrangement of the constituent particles. However, this regular arrangement is sometimes interrupted by certain defects in the crystal, such as point defects and line defects. A defect arising due to the irregularity in the arrangement of the constituent particles around a single lattice point is referred to as the point defect. On the other hand, a defect arising due to the irregularity in the arrangement of the constituent particles across a row of lattice points is referred to as the line defect. In this module, we are going to explore the point defects, which are of three types: stoichiometric, non-stoichiometric, and impurity defects. Stoichiometric defects are so called because they do not bring any change to the stoichiometry of the solid. These defects exist in the crystals of non-ionic as well as ionic solids. In the case of non-ionic solids, the stoichiometric defects exist in two different forms: vacancy defects and interstitial defects. A vacancy defect arises when a constituent particle leaves its lattice site, creating a vacant site in the crystal lattice. Alternatively, an interstitial defect arises when a constituent particle occupies an interstitial site in the lattice. On the other hand, in case of ionic solids, the stoichiometric defects exist as Frankel defects and Schottky defects. In both the Frankel and Schottky defects, the electrical neutrality of the substance remains maintained. Frankel defects arise in the ionic crystals having large difference in the size of the constituent ions. In such defects, the smaller ion dislocates from its lattice site to an interstitial site. Schottky defect, on the other hand, arises in ionic crystals having constituent ions of similar size. In such defects, equal number of cations and anions leave their lattice sites and create vacancies in the crystal. So far you have learnt about the defects that maintain the stoichiometry of a crystalline substance. However, there are certain defects that change the stoichiometry of a crystal. These defects are called non-stoichiometric defects. Non-stoichiometric defects are of two types: metal excess and metal deficiency defects. The metal excess defects arise due to two reasons: the presence of anionic vacancies in the crystal or the presence of extra metal ions. Let's first understand the metal excess defects that arise due to anionic vacancies in the crystal. When sodium chloride is heated in the atmosphere of sodium vapors, then some sodium atoms get deposited over the surface of the crystal. Some of the chloride ions diffuse from the lattice sites to the surface and combine with the sodium atoms to form sodium chloride. The electrons lost by the sodium atoms diffuse inside the crystal and occupy the sites vacated by the chloride ions. These sites are called the S centers. Such a crystal of sodium chloride, therefore, has an excess of sodium metal and thereby develop the metal excess defect. Let's now consider an example to explore the metal excess defects that arise due to the presence of extra metal ions. When zinc oxide is heated, some oxygen gas is released from it. The remaining extra metal ions and free electrons produced during the reaction occupy the interstitial sites, thereby developing the metal excess defect in the crystal. Now that you have learnt about the non-stoichiometric metal excess defects, let's learn about the second type of non-stoichiometric defects, the metal deficiency defects. The metal deficiency defects arise when a crystal becomes deficient of the metal on losing some metal ions from their sites. In such a case, to maintain the electrical neutrality, some of the remaining cations acquire extra positive charge by moving into the higher oxidation state. For example, In the crystal of ferrous oxide, a few ferrous ions move out from the site, resulting into a non-stoichiometric defect. Some of the remaining ferrous ions acquire higher oxidation state and become ferric ions. Let us now learn about the last type of point defects found in crystal lattices of solids, the impurity defects. An impurity defect arises when a cation leaves its site and some foreign cation occupies the vacated site. Such defects are found to occur in crystal lattice of sodium chloride when some lattice sites vacated by sodium ions are occupied by the strontium ions. To maintain the electrical neutrality of the crystal, one strontium ion replaces two sodium ions. So, half of the vacated sites are occupied by the strontium ions while the other half remain vacant. Let's summarize what you have learned in this module. On the basis of their locations, the defects in the crystal lattices are divided into two types: point defects and line defects. Point defects are the irregularity in the arrangement of constituent particles located around one lattice point, while line defects are the irregularity in the arrangement of constituents in an entire row of lattice points. Point defects are of three types: stoichiometric, non-stoichiometric, impurity. In stoichiometric defects, no change occurs in the stoichiometry of the constituents. These defects are further divided into two types: vacancy and interstitial. Vacancy defects arise when a constituent particle leaves its lattice site, while interstitial defects arise when a constituent particle occupies some interstitial site. Non-stoichiometric defects lead to the change in the stoichiometry of the constituent particles. It is of two types: metal excess defects and metal deficiency defects. Metal excess defects arise either due to the anionic vacancy in the crystal or due to the presence of extra metal ions in the crystal. On the other hand, metal deficiency defect arises when a crystal becomes deficient of the metal. In impurity defect, cations in a crystal lattice leave their sites and some foreign cations occupy the vacated site to maintain the electrical neutrality.